Welcome to Kenton Teaches. Enjoy the video.
You start by defining the voice you want, age, tone, and sample rate like 44. 1 kHz. Record 10 to 30 minutes of clean speech with a cardioid microphone in a quiet room. This gives the model the variety it needs. Once done, align each audio file to its exact transcript and name them consistently, for example speaker 01. WAV and speaker 01. TXT, so training tools ingest them without errors. Make sure to include conversational lines and exclamations, so the TTS learns prosody and emphasis. You now preprocess and convert audio to MEL spectrograms, normalizing levels and trimming silence. This ensures consistent input. Choose a TTS pipeline. For natural prosody, use Tachytron 2 with a WaveNet-style vocoder or a lighter end-to-end model if latency matters. Start training with validation checkpoints, then synthesize test phrases frequently to inspect pitch, timing, and clarity. Once you spot artifacts, adjust learning rate, batch size, or data augmentation. Make sure to log changes and use short A/B tests to iterate quickly and objectively. You finish by fine-tuning the trained model on expressive snippets and adding SSML or prosody controls to shape pauses and emphasis. Then export an optimized runtime. Choose CPU, GPU, or mobile builds and apply quantization when necessary to reduce size. If the output sounds robotic, distorted, or muffled, inspect dataset balance for missing phonemes, swap to a higher quality vocoder, and verify denoising thresholds. As a key troubleshooting tip, retrain a small split after fixing data issues to confirm the fix before full deployment.
Thanks for watching. Please subscribe if this video was helpful.